Today I am going to discuss about Pascal's triangle and the powers of 1001. So here I have taken all the powers of 1001 from 1001 to the power of 0 to 1001 to the power of 11. So here you see 1 and then here you see 1001 and here you see 1,000,2001. But you can see these numbers over here, these 3-digit groups are seemingly 1, 2, 1. And then if you add these two groups, you get this one, which is 1 plus 2, 3. So let's go and make a triangle out of this. So let's take a chart. So the first one is, so we'll draw 0, 1, and then the 1 is for here, so then that would be 1, 1, and then if you go on like this, it's called Pascal's triangle. Actually, it's also done probability, but it's also here in here because of one reason. So when you take a plus b to the power of 0 is equal to 1, of course, and because anything to the power of 0 is 1, a plus b to the 1 is equal to a plus b. A plus b to the second power is equal to a squared, because you multiply this times this, because this is the same thing as a plus b, a plus b. So this times this will be a squared, and then this times this will be ab, and then this times this would be AB, and this times this would be B squared. Because when the first one multiplies to the second one, so when there's this and there's also this, it becomes 2 times. When you multiply by 3, it becomes 3 times. So that's how Pascal's triangle is related. But I only told about a plus b to the power s. So how does that have to do with 1001 to powers? That's because if you substitute a equals 1000, b equals 1, a plus b is equal to 1001. So let's use our formulas for that. A plus b to the 0, 1001 to the 0 equals this, which is equal to 1. Simply like that, because that's a law of mathematics. I'll erase this as well. And it's obvious for a plus b, so now let's move on to a plus b squared equals a squared plus 2ab plus b squared, which is equal to 1,000,000 plus 2 times 1000 times 1, which is equal to 1000 plus 1. So we get this because the 1,000,000, and then we also had a 2,000 coming here, and then also we can also keep these ones, 1, 0, 0, 1 followed by no zeros. So we get this pattern which leads to Pascal's triangle. And the next one in this is actually, because Pascal's triangle is the coefficients of this, then this will actually become a cube plus 3a squared b plus 3ab squared plus b cubed. That's why you can get 0, 0, 1, and then there will be another 2 zeros, and then you get 3 here because this is 3 zeros less. Because this is 3 zeros less. That's because 10 to 3 is equal to 1000, and 1001 is the number you are dealing with, and so there is that 1000. So then we get another 0, 0, 3, 0, 0, 1. And as another curious fact about Pascal's triangle, which I'll keep these here, and I'll also extend the table a bit. So this is some more of Pascal's triangle. And then, so row number 0, so let's take the sum of all these. This is 1, 2, actually I'll take the 1 from it. So we have sum is 1, sum is 2, sum is then 4, sum is 8, sum is 16, and then sum is 32, and then let's take the sum. So it's 50 plus 64 then, and then this will be 128. And if we keep the row numbers back in 0, 1, 2, 3, 4, 5, 6, and 7, you notice that 2 to the 0 is 1, 2 to the 1 is equal to 2, 2 to the 2 is equal to 4, 2 to the 3 is equal to 8, and so on. And at the end it's 2 to the 7 is equal to 128. So you can check these if you want. So it happens that this is for the same row and it's exactly like that. Because if we imagine if we take a triangular grid which has lines like this, those don't actually converge like that. Like this actually then. And then there's another one here, another one here, here. So then this will be a 1, 1, 1, and then 1, 2, 1. So you actually get these blank squares, but if you take this one, if you this Pascal's triangle also has this principle of adding like this, which is why all that happens. So this adds to this and this, so it's counted twice. So the whole of, and for this happens twice, and for this happens twice, and the same happens for the next next row and the next row, and and row 0 happens to have a sum of 1. So it multiplies by 2 each time, which means it's 2 to n. And do we need any chains or something? No, because this fits perfectly. This exponent, because the exponential growth is correct. And for 2 to 0 is equal to 1, 2 to 1 is equal to 2. So this actually perfectly works. That's why 2 to the n for the nth row the sum.